Hello, am I audible?
Yes.
Someone confirm?
Yes, sir.
Okay, just give me a
Yes,
minute.
sir.
Okay, yeah, so good afternoon, everyone. Welcome to the session. So this is our second week's first session, right? And generally what we try to talk about in this session is discussing the activity and practice questions and any other doubt in general, what you may have, faced during the course of these 2 weeks. So I just wanted to know how many of you have completed or are in the middle of watching the sessions, the video lectures that we're giving, right? Okay, one. Okay, you're in the middle. Okay, some are in the middle. So so what do? Like you complete watching the entire video and then come up with the questions, or you solve them parallelly? Okay, fine. Yeah, that's good. Yeah, so it gives you kind of so a lot of content does not come in and crop up, so that you just have to take that part of the content and solve questions accordingly. Okay, yeah, so some might so it depends on your comfortability, right? Some can take the entire videos, watch them, and then solve the questions, and others can also solve it parallelly. Depends on how you are comfortable with. Okay, but yeah, but
Sir,
yeah,
basically, we solve the activity questions parallelly, and after watching all the lectures, then we solve the practice and graded assignments.
correct, yeah. So that should be the way to be followed. All right, so yeah, so I have seen some of the doubts regarding this encoding and stuff, right? Just wanted to know you one by one, if there are any doubts, we can start discussing on that, right? Any specific question or any particular doubt, we can start discussing on that. Yeah, so I guess you can unmute yourself. So you can simply unmute yourself or you raise your hand so that you.
Yes, sir. Like in practice assignment, question number 12, how to solve that kind of questions.
Yeah, Viraj, go ahead. Yeah,
Conversion type questions, how can we solve them?
conversion type, is it? Okay, so what is it you want to? So basically, we are talking about number systems here, right?
Yeah.
Okay, fine. Okay, any other particular questions in particular regarding activity practice? Graded we won't be discussing, obviously. See, because there is a reason they are graded, right? So we have a deadline to follow, and those questions can definitely be discussed after the deadline. Okay, so once the deadline is done, we can you people can ask doubts on that. So what we say, so let's say if we are talking about some graded questions that are from week 1 and week 2 and have their deadline in week 3, after week 3 definitely you can ask those questions on anywhere on discourse live sessions. Okay, but before that it becomes a bit so we avoid solving those questions before their deadline, respective deadlines. Okay, any question from practice and the activity will take, and any concept that was there discussed.
Hello, sir.
Yeah.
Sir, I'm having a hard time understanding that UTF encoding, sir.
Okay. Okay, fine. See, that is something. See, what happens is, you while watching the lectures of week 2. So this is a for everyone, right? I guess every one of you are somewhere facing these problems with UTF conversions, right? So the thing is, while watching lectures of week 2, you may have come across something called as context. Okay, so what is that? Context is not only giving the information, but also the idea of how that information is to be used. Okay, for example, let's say I have some information or wordings. Let's say I have some piece of text that has to be transported from one place to another. Okay, shifted from one place to another, but that is not understood by the computer, right? The computer converts it into something that is understandable by the computer. Okay, but once it is converted, once the conversion is done, okay, let's say characters getting converted into binary. I hope this is very pretty much clear that computers understand the binary language, and what we work with are the characters. Okay, so once the characters are converted into binary, these are simply ones and zeros, right? How to interpret what does that one or what does that zero mean? What is the context? Okay, so along with that ones and zeros, we provide additional information. okay, which not only stores the information, actual information, but gives the context of that information. Okay, so this can be understood from the very first question probably you may have seen, that is the representation of character A, right? You may have seen it in the activity question. How is A represented? Okay, so some could have converted it in simply into, you know, the ASCII encoding of zeros and ones. Okay, the decimal representation of ASCII. Okay, and then a simple character A, right? So this depends on what the interpreter interprets it in the form, in what form it interprets, right? So if I give the whatever encoding is there, say 00100, what is it, whatever it is, and along with that, if I say this is the binary encoding of alphabet A, then it becomes more meaningful. The meaning is given to that ones and zeros, right? Otherwise, it's just a piece of 8 bits. Okay, so that is the idea. What UTF-8 does is, so what is Unicode? Any code that is given, that will be given to us will be a Unicode. Okay, now converting into UTF, what happens is, you may have observed that some extra bits are getting added. Okay, or probably the image that we have given as a reference is giving you some rules as to how many bits to be added at the last. Okay, now more than understanding how many bits are added towards the last of each 8 bit, it is important to understand what, not only understand the meaning of what is there in the prefixes, right? The 8 bits that we are seeing, what is there, the 3 times 1, 1 and 0, what is there, what does that represent? So that is actually the interpretation. Okay, so that is actually the interpretation of how one should look at the code that is being followed. Let me explain you this. Okay, whatever I said, I will try to share my screen. Okay, okay, so is my screen visible? Is the whiteboard visible?
Yes, sir.
Okay, okay, so what I'm trying to do here is, so let's say I have an information stored something like this: 11000010. Okay, now I don't know if it is A or not. Okay, leave it. Currently I know that this is just an 8-bit information. It is an 8-bit information which I want to store. Okay, and I know the interpretation of this 8-bit information. Now if this information goes to person B, okay, if this information goes to person B, for him it can be anything, right? He can simply convert it into decimal and say it is decimal representation of this number. Okay, it can, he could, he or she could simply say, okay, this is some 8 bits, randomly written 8 bits. Okay, why does the person B has that freedom? Because he does not know the context by which this information is written, right? So what is done here, while sending this information from person A to person B, I will not directly send this to A to B. I will just add some prefix coding. Okay, okay, and add this information here. So whatever it is, 110 0010. Okay, now what happens is, the actual information is here. How to interpret that information is actually written here. Okay, so that is what is done in Unicode to UTF-8 encoding, right? That is what is done.
Please repeat the last step, sir.
Yeah, so see, don't worry about what I've done as a step. I have not given steps to anything. What I'm trying to do is, if you want to share the exact actual information, okay, the actual information is not directly sent in its raw form. Okay, this information, whatever I've said here, can be called as raw information without any context, because, or information whose context only I know, right? The If I send this information, if I forward this information to some other place, the other machine would interpret it in different various other ways, right? So along with this raw information, I also have to give its interpretation, right? So the actual interpretation plus information is something that is being sent, or that is to be sent, so that the one who decodes this information will not only understand the information, but also know the interpretation, where this information, or how this information is helpful, or how to use this information. Okay, so that is happening in Unicode to UTF-8 conversion. A Unicode number will be simply a hex number without interpretation, sorry, without context. Okay, okay, just give me a minute. Okay, I'll be just back. Yeah, so just give me a minute. All right, I'll just join back. Okay. Yeah, hello.
Yes, sir.
Yes, we
Yeah,
can
yeah,
see.
sorry.
Yes, sir.
Yeah, sorry,
Yeah.
sorry for
Audible. Now
the.
audible.
Yeah, sorry. Yeah, that's what I guess you guys have had problems with some of the background issues, right? So I've shifted to a silent place. Okay, but anyway, is this clear what whatever I'm trying to say till now?
Yes, sir.
Okay, so what I'm doing is the Unicode that we are seeing in the question is actually a hex code without context, right? But converting it into a UTF-8, what it will do, it will simply keep it, the code will be again hex, okay? But it will have some context. Okay, that is the issue. Now that is the solution to that. Okay, and that is only thing that we are doing with that conversion. What is the context? We don't have to really bother about it. Okay, that is something that computer understands. Okay, for that, and again, we don't want every one of you to know, okay, if this is the number of digit, what should be the prefix coding? If this is the number of digit, what should be the prefix coding? I guess you have been given with some rows, right? 1 2 3 4 rows, where it shows that what should be the minimum length, or minimum length that can be stored in that particular, or in what area it comes, right? So in that case, we don't want you to again memorize that. Whenever this type of questions appear, you will definitely be given this table so that you can refer. Okay.
Sir, if you could explain that table, I mean, in the if you see the lecture slides, it's
Yeah, go ahead. Hello.
slide number 18, sir. Slide number 18.
Okay, okay. Just can you read out anything that you want to say about that slide?
I mean, sir explained, professor explained how to how this whole table works, but I cannot. I was not able to understand it. So if you can explain, it would be really helpful.
Yeah. So should I explain that question?
It's sir, it's not a question. It's a whole slide, sir. Like first byte, second byte. It is about
Yeah. So if I see there is, have you gone through the questions, the practice questions?
practice. No, not yet, sir. I have gone
Okay.
through the activity.
See. Okay, fine. See, so there is a question in practice assignment, okay, which talks about conversion. Okay, this prefix coding. Okay, so once you get to see that question, you will or you understand that question. That is the maximum that you need to know about prefix coding.
Okay,
Okay.
sir.
Yeah. So yeah. So the conversions given in slide are just for the information. You don't have to. You don't have to. Okay. Understand. Not really understand. You don't have to mug up actually what is the conversion from here to there. Okay. You don't have to worry about that. The table that we see, what we have done is we have abstracted the useful information from that entire piece of information given to you in slides and put it in the form of question. Okay, once you understand that question, that should be more than sufficient to understand whatever is there in the prefix coding.
Yes, sir. Can you please explain that question as well, the 12th question in the practice assignment?
Yeah, that's what. So what I'm trying to do is yeah, so that's what I thought. Better to explain that question, and in that case, you will be in a better position to understand what you need to know about prefix coding. Okay, so what I will do is I'll temporarily stop this sharing. Okay, and yeah, sorry, someone speaking. Okay, maybe it was okay. Anyways, all right. So what we want is I'll open that question for you. By the way, is that the only doubt? Otherwise, no doubts in the activity questions?
No, sir, no doubt from the activity.
Okay, fine. That's good. Okay, how many of you have started working with HTML? I guess the lab assignment question
sir.
statement is still out, right? So
Yes, sir. I have submitted the assignment.
submitted the assignment. Very good. Fine. I hope you have tested it before submitting, right? The test run and
Yes,
all.
sir. That shows 100 out of 100.
Okay, fine. Okay, but see, one thing, this is a general information for everyone, right? You have to strictly follow the question statement. Okay. See, a particular thing to appear on the page may have multiple HTML. Okay, meaning you can render same thing by creating multiple HTML and still have the same result. Okay, so even if you are seeing what is expected as a screenshot, do not completely rely on that. Okay, just make sure you have strictly followed the question statement. Okay, because the evaluation that is being done will be stricter than what it is showing currently. Okay, and that depends on how well you have followed the question statement. Okay, so even if you're submitted, there is still time. I'm not saying that you have committed some mistakes here and there. Just wanted you to know that the thing is, even if you are able to do a test run and get full score, your code will be tested against more test cases at the backend, right? And there for that you need to, and that will only get clear if you strictly follow the question statement. Okay, the question statement are 3 to 4 pages long for a reason, right? Okay, so every information is strictly given, and we expect you to, every one of you, to follow that information, that piece of information that is given in the question statement, and write your code accordingly. Okay. Yeah, so it's really good that you have been able to submit the code in very less time, but just wanted you to cross check. Okay. Yeah, so this is for everyone. Okay.
So, sir, is it necessary to include the same number of tags as mentioned in the document? Or like we
Same
can
number
have
of
tags, HTML tags?
yes, you have to stick to that.
Okay. So earlier, sir, I was mistaken. Like I did there was a page named academic, so I named it as academic only, and it was not working. Then I later changed the name to academics, and it worked.
Yeah, that's what. So even the text that we are giving, the sample screenshot that are there, which it is not only for your reference, but you have to strictly follow it. That is the whole idea. Okay. Yeah. So this is the question, right? So what does it say? You have to compute the UTF-8 representation of Unicode point U plus 543A9. Okay. Do not worry about this U plus. Okay. This U plus only represents that it is a Unicode point. The only thing that we need to look at is,
Sir, if you are presenting something, it is not visible.
oh, I'm really sorry. Just give me a minute. Yeah, okay. Yeah, so those who have not even started lab assignment, no issues. Just make sure you complete it before the deadline. Okay. Okay. Anyways, so is the screen visible now?
And sir, what about the CSS assignment?
CSS assignment is completely for your practice.
Okay, sir.
Okay. CSS assignment has to be built on built on the HTML assignment that you will be creating. Okay, but you need to submit only the HTML. You don't have to submit CSS. Whatever you want to add as a design completely depends on you. This is for your own practice. Okay.
Sir, I have a doubt regarding the CSS.
Okay.
So, sir, we just started CSS, and now we are getting an introduction to Bootstrap and all that. So, should we learn bootstrapping? I mean, at this stage, should we learn that by heart, or
No. Learning anything, not only this stage, the entire course, you don't have to learn anything by heart. Okay, you see, bootstrap, you should only understand how something has to be embedded. Okay, for example, if I want to give a login form, okay, let's say I want to create a web page that has a login form. Okay, can that form be created by using simple HTML? Definitely yes. Okay, can I provide certain styling with the help of normal CSS? Definitely yes. Okay, if I want to use bootstrap, I should be able to know how to embed that particular bootstrap or that particular file into my HTML document. Okay, and then use its predefined classes. Okay, again, you don't have to learn what predefined classes there in the bootstrap. Okay, you can refer to, for example, login page, right? So you need two text field, for example, username and password, and then a submit button. Now how you want to do it, just it depends on you. Now if you're choosing bootstrap, what you need to do, you need to just see or look at the stylings of the text fields and the button. That's it. Okay, and then just refer to the documentation that they give and then add that particular part in your code, right? So simply embedding the link of bootstrap is not enough. You have to use the classes for the real design to come up.
okay, sir? And
Okay,
in this course, are we going to learn CSS and HTML?
definitely. The second week, I guess, after the coding, the encoding and this conversion from one form to another of this the numbers, we deal with HTML and CSS only, right? Although it is not given in much detail, but the basics are covered so that you can build on it.
So, sir, are we supposed to like study all this topic in detail by ourselves, or it is not necessary?
Sorry, can you come again?
Sir, what I'm asking is like, are we supposed to study all this HTML and CSS in detail by ourselves, or it is not necessary for this course?
See, HTML and CSS, where to end is dependent on you. Okay, we will give you how to start. Okay, so the content that we have given you will give you some theoretical information about HTML and CSS. Lab assignments and the live sessions will help you to understand how actually to create a HTML form, HTML pages, and give styling to them with the help of CSS. I guess. Okay, so that should be sufficient for you to understand, okay, this is the basic and this is how I should learn if more things are to be added in the HTML. Whatever will be required for the course will be given by us.
Just a general question, like after this MAD1 and MAD2, are we eligible for like front end developer kind of jobs or?
Yeah, definitely you will be.
Okay.
Front end, see, the MAD 1 and MAD 2 course together deal with the entire stack. Okay, the front end and back end. MAD 1 particularly deals with the back end.
MAD 1 deals with the
Back end, yeah, the server side.
But we are dealing with the front end. No, sir.
Sorry.
Sir, we are dealing with HTML and CSS. So, as per my knowledge, that is the front end. No, sir.
Yeah, absolutely. If HTML and CSS are front end, but see, you are creating a server and that does not have any HTML page. How will you understand what is happening at the server? Some basic has to be given, right? And do you think HTML and CSS that is all for that is there in the front end?
No, I think another subject, another language is there, that is JavaScript. And other than that,
Yeah, correct. So there is see, it's ultimately it's all HTML. Okay, but you just to get a glimpse of what websites look like, you will you should know what HTML is. Okay, to know what your backend is serving, right? What pages it is serving, how it is giving styling and all, how it is retrieving data and data from the database and showing it to the user. For that you need HTML. So basic knowledge of HTML is required, right?
yes, sir. Yes.
Okay, now to what extent you want to add design, for that we will give you basics of CSS. Basics, okay?
Okay, sir.
If we go with the bootstrap, then again, there will be screencast which covers basics of bootstrap, as in how you need to, so it will be like giving you the structure. Now, whatever you want, you can just go to the documentation and add it. How to do that, that will be given by us. Okay. Now, once we are done with the HTML and CSS, just the information or the introduction of HTML and CSS, sufficient enough to create a proper web application, we will jump into backend. Okay, and then mostly deal things in the backend. Okay.
Okay, sir.
Sir, may I ask a question?
Yeah, sure.
Web application and website, both are same thing or different thing?
Web application and website are you can say they are same thing, but website is a broader detailed version of a web application. A web application can be as simple as just put your name and get it displayed on your screen. That is a web application. Okay. A website is a more detailed version where you have the login part, the information, the database connectivity.
Once we are conversant with this development of this application development, whether we will be also able to develop the website?
Yes, definitely.
Definitely. Some design addition will be there only, right?
Yeah, that's what. So websites is not only what you see, right? It is there is a lot happening at the backend. So that's what. So this course deals with whatever is happening at the backend of that website. For example, if you see the screen, right? This seek. So this is something. This is the portal that we are looking at now. This information, this question numbers, this screencast, and all these are simple HTML and CSS. But how are they coming to this point and showing you the specific data? For example, see, we have not released week 3 content, right? We have content for week 1 and week 2 only. How does the application know that not to present data for week 3? So that is happening at the backend, right? Whatever backend shows, backend gives, it will show on the front end.
Okay, fine.
Okay, so see, any web application is incomplete without front end or backend. You cannot say that I'm learning backend, so I'll only work at the server end, or I'm learning front end, so I'll only work at the client end. Okay, so it's not like that. It is definitely both, but how detailed you go in one depends on what you're exactly studying. Okay, so we'll start off. So in the first 3 weeks, we'll work with the both, right? The front end and back end. But this is week 4. When it comes, we'll start off with the completely back end, because whatever is required for a front end will be dealt with in first 3 weeks.
Yes,
okay, we will also, along with the, I hope screencasts are giving you enough understanding of the practical sense of what is to be done, but we will also take solve with instructor sessions, right? So that will also help you where you can ask your personalized doubts.
And sir, will there be
go ahead.
Sir, one more question. In the
Yeah.
last 1 week, week one,
Huh.
some HTTP /1 version 1.0 200 OK codes were there. I installed on my system desktop Ubuntu,
Okay.
but the terminal was not processing the code whatever written in the lecture. I was not able to process that because it was not accepting.
So are you using Windows system or you had Ubuntu
Windows,
already
Windows,
installed? You're
Windows.
using Windows, right? So you don't need to
Yeah.
switch to Ubuntu. You can do everything there is in the on the Windows.
Directly on the terminal.
Yeah, definitely. So see,
Okay.
even in the previous live sessions, probably on Wednesday only, I said that even though you do not have Ubuntu, desktop, or you're not familiar with Linux system, you don't have to worry about it. There will be, let's say, out of 100, 1 or 2 commands will change, which are easily gettable from internet. Okay, what is the command for this? Otherwise, you won't even need command line. Okay.
Okay.
We will be dealing with command line interface very briefly, just to get the glimpse of what is there at the backend. Okay. Otherwise, things will happen from on the. You can definitely use Replit and all the local IDs. Things will happen there only. Okay. Now, Replit being a platform independent website or a platform independent, web app, you can definitely use it in any system. Even I'm using Windows system, right? So most of us here use Windows system. If one screencast or one videos that is coming on Linux, you don't have to switch the entire system to Linux. Right? This is
There
application
is no need to
development.
go there. Just do on the terminal window of the Windows. Okay.
Yes, the very first lecture also says that web applications, or why are we using web as the platform? Because it does not require any specific operating system.
Yeah. Okay.
Correct. So you don't have to worry whether it is Windows or Linux. Those who have Linux, well and good. Those who have Windows, well and good. Those who have Mac, well and good. No issues.
Thank you.
Okay. Yeah. Somebody raised hand before.
Sir, I was asking, these lab assignments will be there in all the weeks, right?
So you'll be having them till week 7. I guess there are 6 lab assignments.
Okay.
Okay, so we started with basic HTML. Okay, CSS, as you can see, as you may have read the problem statement, you may have seen that now this is something that you are adding, designing or styling to whatever you have created as a part of HTML, right?
Yes, sir.
Yeah, so from this we can infer that all the lab assignments that are coming forward will be the build up, the thing that we have done in the solve with instructor sessions also, right? Started with very simple and then tried to build the concepts. Okay, so in the lab assignments also, same thing will be followed. Starting off with basic HTML static files to be served, then designing, and then we'll keep on adding things. Okay, so it's not that jumping to any of the lab assignments is not allowed, but you might face some problems because you don't have the link to previous ones, right? Also, on the other hand, I'm not saying that you won't be able to do lab assignment 4 because you haven't done any before that. Okay, every lab assignment will have a specific question statement that has to be followed very strictly. This is a common statement across the lab assignments.
Okay, sir.
Yeah, all right. Yeah, somebody raised hand, I guess. I didn't.
Yeah, sir, I had raised my hand. I just wanted to clear that we'll be submitting only the HTML assignment and no CSS would be there in it, but we won't have to use inline styles, right?
No, see, style sheets are anyway. So if you at all want to use CSS, then only you will have, you will have this question in mind whether to have the inline or internal or whatever it is.
Okay,
right?
okay.
If you're submitting only HTML, you don't have to worry about that.
Okay, sir. Okay. Just
So
wanted to clear that.
Yeah, so the instruction that you are probably talking about, the inline and all, it is given in the CSS lab assignments, and there we recommend you to go with the external style sheet.
Okay. Okay, sir.
Just to keep the both the files separated.
Okay, sir. Okay. Thank you.
All right. Yeah. Yeah. Any other doubt?
One question was there, sir. The ASCII code for the space key. You know, how whether we have to remember every key is ASCII code or we have to some method to calculate the key.
All right. So ASCII, see, 8 bits, I guess, have 256 characters. Okay, so it is practically impossible to memorize all 256 characters. Even if I talk about ASCII 7 bit.
Question was there.
Yeah, definitely. So the question is there just to give you an idea of, okay, that space also has a character encoding. This is something that has to be taken away from that question.
And how to get this ASCII code?
You simply search it on the internet. What is the ASCII for?
Okay. After searching, we can write the answer. No problem.
Yeah. No issues with that. See, what happened? You went to the question and you did not know the answer for that. You went through the internet and you understood that, okay, there is even if you're talking about characters and they may have some or the other encoding, even the space has an encoding.
I understand that, but I just wanted some method whether because the question is being asked based on the lecture. I was searching the lectures where how to calculate.
No. Don't have to worry
it is
about
not
that.
Like that. We can go to the internet and get the answers and put in there. Okay.
Correct. So if you go to the question and if you see that, okay, I've searched this question from the internet, but there is no way I could have known the answer if I had not searched this. Okay, this means that this is memory based. Okay.
Okay.
Then you have to leave it there only. Don't have to worry about that.
Thank you.
Okay, fine. Okay, any other doubt? Yeah, so those who have not been able to solve these questions, maybe because of time constraints, and you maybe some or the other, maybe the working professional, so could not find time, you can definitely go through the lectures and solve the questions. And if there is a doubt that sustains, you can definitely go to the discourse and ask the same question. Okay, or the session what we are giving it now is available on the YouTube also, so you can refer to these sessions also. Yeah, so but those who have solved, I hope so there are no doubts, but if still there are any doubts, we'll try to talk on this. So like we'll try to have a interactive session. It has been interactive till now, and I would love to take it forward this way. Yeah, so I'll anyway solve this question. I'm not skipping this. Okay, so don't worry. Okay, so I assume there are no more questions. Let's go with this question then.
Yes, sir.
Okay, so I'll just take this word here. It is U plus 543A9. Okay, so is the screen, the whiteboard is visible?
Yes, sir, it is visible.
Very good.
Okay, so our number was U plus 543A9. Okay, so this is Unicode. Okay, how do I know it is a Unicode? Just this. U plus represent that it is a Unicode number. Okay, now how do I understand what the format or what we say the representation of these numbers? What do I mean this? With the representation is the base. Okay, so I hope you understand that there are numbers.
This is hexadecimal.
Yeah, correct. So it is a hex. These are hexadecimal numbers. Okay. But even if I didn't know that, okay, if it was hexadecimal, how could I have understood from this
A.
Right? So for those who don't know about this, we have certain way of representing numbers. Okay, the numbers that we understand and deal with in our day-to-day world are decimal numbers. Okay, so decimal numbers start from 0 and they vary up till 9. Every other number is the combination of these numbers, right? The other number which we may be familiar with are the binary numbers. Okay. So the binary numbers are only 2, 0 and 1. Okay. And decimal numbers, the total is actually 10. Binary is the total is 2. Why? Because we have to consider this 0 also, and it has a very important place in any number system. Okay. The other is hexadecimal. Before that, there is one more system that we generally talk about is octal. Okay. Now, with the trend that these number systems are following, we can say that oct means 8. So if total numbers are 8 and we start with 0, we will end up with 7, right? So in octal number, there are 8 numbers ranging from 0 to 7. Okay. Then comes the hexadecimal number. Hexadecimal number systems, which again starts with 0 and has 15 as its last number. Okay. But the problem with this 15 is it is 2-digit. Okay. So if I start with 0, 1, 2, 3, 4 till 9, then I have this 10, 11, 12, 13, 14, and 15. Okay. Now it becomes very difficult to say either these two numbers are 1, 1 or 11, right? 1, 2 or 12. Therefore, we come up with representing them in the form of alphabets. Okay. So now they till 9 it is single digit, right? But from 10 it comes to the 2-digit. So we convert this or represent these numbers in the form of capital alphabets. That is A, B, C, D, E, and F. Okay. And A, B, C, D, E, and F, which has this 1-to-1 correspondence, right? So 10 represents A, 11 represents B, 12 represents C, 13 D, 14 E, and 15 F. Okay. Now, it is also important to understand that this binary will be generally represented by 1-digit number, right? So it is 1. Either you can put 0 or you can put 1. Okay. Then we have octal. Octal numbers like 0 to 8, sorry, 0 to 7. If I want to represent them in the form of binary, okay, an octal number represented in the form of binary, I will have to take 3 digits, okay, or 3 bits. 3 bits is something that I could represent each and every basic octal number, because 7 being the highest. And does anybody know the binary representation of 7?
1.
It's 1, 1, and 1. Okay. And with the same reason, if we move ahead, we will see that the hexadecimal numbers will require 4 binary bits. Okay. This 15 will be 1, 1, 1, and 1. All right. So these are some basic things that we might have learned before in the number systems, right? So anyone who has no idea about number system, what are these numbers? What are these octal numbers? What are these hexadecimal numbers?
It is clear, sir.
Yeah. So I guess many of you have basic idea of what these are, right? Any issues with the convergence of one system to another?
Yes, we can do, sir.
Okay, fine. So that's great. Okay, let me select.
But we can do from going to the decimal, then go to, if suppose we want to convert from hexadecimal to octa, then we have to go to the decimal, then go to the octa. Is it so, or directly we can go from hexa to octa?
Okay, see, hexadecimal to octal number. Okay, so you want to convert this hex number to decimal and then go with from decimal
hex
to. Okay, have you tried with converting hex to binary?
Yeah. Okay.
Okay, let's see this number. Okay, now we are diverting from the real example. Okay, but just let me give you this idea. Okay, so let's say this is 5, 4, 3 and A. Okay, so this A means, I guess, 10, right?
10.
All right, and as I said, every hexadecimal number has to be represented by 4 binary bits, right? So how will I represent this 5? It will be 0, 1, 0, 1, right? 4 would be 0, 1, 0, 0. 3 would be 0, 0, 1, 1. And A would be 1, 0, 1, 0. Any issues here?
Okay.
Okay, what I did here, I just converted these hexadecimal numbers into binary. Everyone clear, right? I'm just converting a hexadecimal number into binary, and with the law means the rule that I have to take 4 bits for representing every hexadecimal number. Now, why this is necessary? Because if you see, 5 is just 101. Okay, but still I'm using 4 and putting a 0 here, right? So that is the thing. That's why I'm saying I have to mandatorily have this 4-digit used. Okay, now this is hex, right? What I'll do is I'll make the pair of 3 from here. Sorry, this and then this one is different. Okay, let me remove that. Okay. So what I've done, I've written the hexadecimal number, converted into binary, which was pretty simple because converting this hexadecimal number into decimal would have been a bit trickier. Okay. And now what I've done is I've taken the group of 3. Initially, I had written this in the group of 4. So what was written initially? This, and this. This was written, right? Okay, now what I've done is I've taken this numbers and put it in the group of 3. Now what I'll do, I'll convert each group into its into decimal. Okay, let's see what happens. This is 2, this is 7, this is 0, this is 2 again, and this is 5. Okay, so the number here, what is this? 16, right? Hexadecimal number. The number that I got here is 8. It is octal representation. Okay, just one step, no conversion into decimal.
How did you do this, sir? How this conversion from octal?
See,
did not get this.
Yeah, see, so what happens is any number that you take,
Yeah,
the binary representation of that number will be same, right?
Yeah, 5, 4, 3 and A has been written directly into the binary in a sequence.
Yeah. So what happens is, as I said, this this thing that I'm saying is really important. If it is a hex number, every number has to be written in 4 bits. Similarly, if it is an octal number, every number must be written in the pair of or in the group of 3 bits. Okay. So if I take 4 at a time, this would have been the hex number, which is this conversion. What if I take the same number and make a group of 3? Now, if I made the group of 3, each number can be converted into an octal number because I know that binary can be represented.
How did you decide the octal number will be represented in the group of 3 only?
Because the maximum number in octal system is 7, right?
Yeah.
What is the binary representation of 7? 1,
Okay,
1.
highest. Yeah, highest. Right.
Yeah. So
the highest number will be 3.
Yeah. So highest number will be 7. In octal system, what comes after 7? What will be the next number after 7?
After 7.
0.
No. I'm not saying we are going back here. I'm saying what is, let's say if I'm in a decimal system, what is the next number? 11, right? In the octal system, what is the next number?
11 0, sir.
Sorry?
No, 8. It is 1 0.
Yeah, it's 1 0. 10.
1 0.
Okay. Okay, leave it. Do not get confused here. But I hope you understood this thing, right? 3 bits. So if every octal number can be maximum, the requirement of maximum number for every octal number is 3, can represent in the group every number or the entire binary string that I'm having in the group of 3 and say that it is a combination of 8-bit numbers. Sorry,
starting
3-bit.
Starting from the right, sir, or left?
Starting from the right.
Right. Okay. Fine. Okay. Thank you.
Okay. Why so? See why I'm saying starting from the right. Starting from the right, because just have a look here. Let's say I have a number like this: 0 1 0 1 0 1 1 1 0. Okay, just a random binary number. Okay, what if? So how many are these? Let's say I've started from right now, left. Now I've started from left. Okay, this is cool, right? 3 3 3. I had 9 numbers, no issues. What if I had this? This was the case.
If it is 10 or 11 digits.
What will happen if I do this here? Make 3 bits. I will have this 1 bit. Okay. Okay. So if I want to convert this 1 into 3 bits, I'll add 2 zeros here, right? Okay. Now if I add these two zeros here and compare and see the original number 0 1 0 1 0 1 1 1 0 1. This was the original number before adding zeros. Okay.
Yeah.
Are these numbers same?
Yeah, this is the confusion.
Right? These numbers are definitely different. Why? Because their place values have changed now.
Yeah.
Okay, let's try to take a smaller example so that I can explain. Let's say I have 1 1 1 0. Okay, so this is the original number. I want to convert it into octal. Okay, the right way would be making groups like this, right? Now, if this is 1, I can add zeros here. Okay.
Yeah.
Okay, now let us try to find the decimal equivalent of this number. What is the decimal equivalent of this number? 14. Okay.
Yeah. 14.
Now,
14.
This was done when I started grouping from the right. Grouping from here. Now, my original number was this. If I had started grouping from here, one number would be this. The other number would be this. Correct? Another group. Now, if I do the decimal, if I try to see the decimal representation of this number, what is this? 0, 1, 2, 3, 4, 5, right? So it would have been 32 plus 16 plus 8. Yeah, 32 plus 16 plus 8. How much it is? 56. This number would have been 56. Our 14 became 56. Okay. If I add, so if I try to make the group from right, my number will be 0, 0, 1, 1, 1, 0. Okay. Even after adding zeros from the left, on the left side, it will have this number. What is the decimal equivalent? It will still be 14. Right. So we have to make groups from right. Okay, so we have to start from here and move here, the way we have done here.
Right, sir.
Yeah.
Got it. Thank you.
Yeah. Any other anyone else who did not understand what I just spoke 5 minutes from the last 5 minutes? How to convert decimal to binary? I'll take an example to that. Okay, Satyam. Okay. By the way, any confusion here? I guess there are some, but if you go through this lecture once again, I hope they will get clear. But if still there is any doubt, just let me know. We'll try to discuss that. Okay, no issues. Okay, so this is one way, and I guess a simpler way of converting hexadecimal. Yeah, somebody was speaking.
No, no, fine, sir.
Okay.
Go ahead, sir.
Yeah, just give me a minute. Just give me a minute. Yeah, sorry. Am I audible?
Audible, sir? Yes, sir.
Okay, fine. Okay, so I hope this part is clear, right? Let me take an so if that is possible now, I'll take one example for how to convert decimal to binary. Okay, so Satyam, when I was converting this decimals to binary, were you facing any problem? Yeah, could you explain how to convert hexadecimal to? Yeah, fine. So decimal to binary, hexadecimal to binary will be one thing only. Just give me a minute.
For conversion purpose, it is required to remember the binary code of the 1 to 14. It will be easier then, right, sir?
Yeah, correct.
Right now, if we remember it, then it will be easier to convert immediately.
Yeah, correct. That's yeah. So see, anyway, we can do that. But the thing is, it will be definitely better to just know. So, for example, see, for if I have 0 to 1, okay, let's do with the take all the numbers from of hexadecimal, and then we'll have a binary equivalent of those. I will also show you how to convert, but just let's have a idea of that. Okay, so initially I have this number 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Then here I won't write 10, right? I'll write A, B, C, D, E, F. Okay, so these are all hexadecimal numbers. Okay, but you need to understand that from 0 to 9, these are decimal numbers, normal decimal numbers. Okay, so hexadecimal number is just extended from decimal. Okay, now you want to see the binary equivalent. Now these are hexadecimal, right? So how many bits should I take for binary? 4. Okay, so I represent 0 as 0, 0, 0, 0. 1 as 0, 0, 0, 1. 2 as 0, 0, 1, 0. Okay, 3 as 0, 0, 1, 1. Okay, 4, 0, 1, 0, 0. 5 is 0, 1, 0, 1. 6 is 0, 1, 0, sorry, 0, 1, 1, 0. 7 is 0, 1, 1, 1. Okay, so the way we had 7, right? 1, 1, 1, 7. 8 is 1, 0, 0, 0. 9 is 1, 0, 0, 1. 10 is 1, 0, 1, 0. 10 as in A. P is 1, 0, 1, 1. C is 1, 1, 0, 0. D is 1, 1, 0, 1. E is 1, 1, 1, 0. And F is 1, 1, 1, 1. Okay. Now, anybody wondering why I was able to write this? Not wondering, right? Okay. If you want to, okay, initially learn, you can simply follow the pattern, right? So you can see that you're using 4-digit. First 4 will be zeros, last 4 will be 1 here. Then make group of 4. So first 16, right? 16 divided by 2, 8. So first 8 will be 0, next 8 will be 1. 8 divided by 2, 4. So first 4 0, next 4 ones. First 4 0, next 4 1. 4 divided by 2, 2. So first 2 zeros, next 2 ones. Okay, and then 2 divided by 2, 1. So 1 0 1 0. Simply follow this. Okay. Okay, so this is something that you can remember. Even if you don't, that is okay, but this will definitely increase your speed of calculations, right? So initially we had this 5 4 3 a 9, right? So what I did, I took 5 here, 4 here, 3 from here, and 9 from here. Okay, that's what was represented. Now if I want to convert a decimal number, in general, if I want to convert a decimal number to binary, there is a method called as division This is I. Okay, division remainder technique. Okay, what is done here? What I'll do, I'll just take a number. Let's say I've taken 27. Taken this number 27. Okay, now if I divide this 27 by 2.
What is it? T, sir? T? Division
Technique,
remainder?
technique.
Technique. Okay, fine.
Okay, now what I'll do is, if I divide this 27 from 2, divide this 27 by 2, what should I get? I should get 13, right? Is it completely divisible? No. So in that case, I'll have 1 year. I'll write 1 year. Okay. What if I now divide this 13 by 2? What will I get? 6. Is it completely divisible? No. So I'll write 1 year. I'm writing the remainders, by the way. If I divide 27 by 2, I will get 13 and I'll get 1 as a remainder. Okay, so what I'm doing, I'm writing this number here and this number here. And 2 I'm not writing because I know I'm converting into binary. Okay, now if I divide 6 divided by 2, what will I get? 3. Is there any remainder? No. If I divide 3 by 2, what I'll get? 1. Is there any remainder? Yes, 1. Okay, and then finally 1 divided by 2, so I'll have to go to 0, and then finally there is 1. Okay, so 2, this 1 has to be divided by 2, and then you have this 1 remainder. Okay, I hope this is understood, right? Now what I'll do, I'll collect these numbers like this. What is the collect these numbers as in? I'll take this as first. So first, this is 1 1 0 1 1. Okay.
Yes, sir.
Hello.
Yes, sir. Fine.
Yeah. Was somebody speaking?
Yeah,
Yeah. Please go ahead.
so I have a doubt in that, like you have taken from bottom to top, right? Like numbers. Is there any method to remember that? Because I'm just frequently forgetting that.
See, there can be only 2 ways you can take, right?
Yeah.
From top to bottom and bottom to top. So if you take the other one, it will be wrong. So you have to definitely take from bottom to top. I'm not getting why are we talking about method? I mean, can you please elaborate?
Like sir, I know that this whole method, but I always forget that which one I should take. Like,
Okay. No. See, this is in this method. You tell me what is there to remember. Only this selection, right? There is only one thing to remember here. And see, if when you are done with when you are very familiar with conversions, you won't even do this division remainder technique. This is very premier, right? We are just doing this for the sake of doing, for understanding how these conversions are happening. Otherwise, we can simply I'll also tell you another way. Okay, so let's say I'll just tell you a simple another way, although that cannot be extended to very long numbers, but we'll not be dealing with very huge numbers in decimal. Okay, for smaller numbers it is okay. All right, so this 11011, now this is the binary conversion of 27. This is the binary conversion. Okay, you don't have to believe me. Okay, what we have to do is we'll just simply convert it. Okay, with that we'll also learn how to convert binary to decimal. Okay, so if I have this number 11011, okay, so what we'll do, we'll try to convert it into decimal. How to do that? We'll try to take the place values and base values. Our base value is fixed because we are converting into binary. Our base value is fixed, that is 2. Now I'll take the place value. What is the place value? We'll start off from the again the right. Mostly we do things from the right, so there, I hope there is no confusion. Okay, so the place value here is 0 1 2 3 4. Okay, now what I'll do, This means I have to raise this power of 2 till 4, okay, and put a proper prefix in front of that. Now let me tell you, let me write what I've said. Okay, so we'll write 1, okay, 1 into 2 raised to power 4, okay, plus this 1 into 2 raised to power 3, plus this 0, right? So we'll write 0 into 2 raised to power 2. Why I'm taking this 432? Because these are the base values. Sorry, these are the place values. What are the base values? It will be 2 always. Okay, has to be multiplied with the prefix. Okay, or what we call as coefficient. Okay, then this 1 into 2 raised, sorry, this is 1 into 2 raised to, okay, so this is where my screen ends, so I'll add it here. Okay, so plus 1 into 2 raised to power 1 plus 1 into 2 raised to power 0. Okay, so this 0 plays an important role. Okay, so what we are doing, we are, so these, if you see this 4 3 2 1 0 are nothing but the powers. Okay, this 2 remains common. What changes? This coefficient, right? 1 1 0 1 1. Now if I add this, what I'll get? 16 plus 8 plus 2 plus 1, right? What does it add to? 27. So this is the decimal equivalent of this number, right? So now we have converted both the ways, right? Converting a decimal to binary and a binary to decimal. Okay, for converting decimal to binary, we'll use the DRT, that is division remainder technique. Conversion from binary to decimal, we'll use this. Okay, now so generally what we'll do is this 27, right? So I'll simply break it in the power of 2. Okay, 16 plus 8, 16 plus 8, how much? 24. What comes after 8? 2 raised to power 2 raised to, this is 8 is 2 raised to power 3, so 2 raised to power 2 is 4. So if I add 4, what will happen? It will become 28, right? So I'll not take 4. Okay, what I'll take next? 2 raised to power 1. 24 plus 2, 26. Okay, this can be taken. Then 2 raised to power 0, 1. Okay, this can be taken. This means this, it will, I will have 1 at 4th place, that is the power 4th place. 3rd place, I will not have at 2nd place. Okay, then I'll have for the this place 1st place, and I'll have for the 0th place. That is what we have done. The same number we got, right? So what we do, we try to make the number from the powers, from the values that we get from powers of 2. Okay, if any number doesn't add up, we'll just put 0, or we'll not take that number. That's it, right? This shortcut you don't have to worry about. Whatever I have given here in DRT and in this conversion, this is something you have to remember. If this is clear, conversion from binary to decimal is clear, then you can go from any number system to any other number system, right? Conversion from hex to octal is pretty simple, right? It is a matter of one step. Only what is necessary, you should be able to have a good correct conversion of hex to binary. So conversion of hex to binary is important. Conversion of and that too. Why hex? Because it will mostly consider a decimal, right? So understanding or knowing the conversion from decimal to binary is sufficient enough to switch from any number system. Right? Is this part clear? Somebody was asking, right? There was one person.
Yes, sir.
So Ajit said, could you explain how to convert hexadecimal to binary? And Satyam, yeah, you both had asked, right? So I hope this conversion is clear. Okay, you can rewatch this part probably later so that you get the depth. Okay, fine. So this is the conversion that we generally perform. Now we'll move ahead with the same question, right? If this conversion is clear and you can understand the table that is given, the question is pretty simple and straightforward. Okay, so what was the number? Sorry. Yeah. Yeah. So number was 543A9. U plus 543A9. Now I said that you don't have to worry about this U plus because it only represents that it is a Unicode. Okay, what is important to us is this 5 digits. Okay, now we will convert these 5 digits into binary, right? So I'll again write fast. Okay, I hope you understand now how I'm writing it fast. Okay, so it will be 0 1 0 1 for 5, and again since it is a hex, I'll represent each binary when I'll be representing this each digit in binary, I'll represent with the 4 bits. Okay, so it will be 0 1 0 0 0 0 1 1. A is 10, I guess, right? So it will be 1 0 1 0, and 9 is 1 0 0 1. If you note one thing, if there is any number, any even number, okay, 2 5 6 8 9 0, and if you convert it into binary, the last digit will be 0. And if there is any odd number, 1 2 3 5 7, and if you convert it into binary, the last digit will be 1. Your last digit will be definitely 0. Your last digit will be 1. Okay, now if you see 5, last digit is 1. You see 4, last digit is 0. See 3, it is 1. A means 10, right? So last digit is 0. 9 1. Okay, normal observations. Okay, so this is the hex code converted to binary. Okay, now we will use the table that is given to us. Okay, so okay, how many digits did we have? 5 hexadecimal digits, right? So, and each digit represented in the form of 4 binary bits. Okay, so how many total binary bits we are having? 5 into 4, 20. Okay, now if you see the first row, it says free bits, right? So these are the maximum, these are the bits that you can encode using this byte. Okay, if I want to use only 1 byte, I should have 7 bits number. Okay, then only I can encode 1 byte. Okay, that is the understanding, or that is the interpretation. Okay, if I have 11 bits to code, or if I want to use 2 bytes, I should have only 11 bits to code, not more than that. Okay, similarly with 16. Okay, if I want to move to the third byte, I should have not more than 16 bits or free bits that we call. Okay, so if we see, we have 20 free bits to code, right? 20 free bits, which will not come in any of these criteria. It will come in the last one. Okay, it says you should have 21. You can code, or you can store up to 21 free bits. We are having 20, right? How to make 20 to 21?
You are talking about screen is visible. Are you writing something?
No, I'm not writing. I was showing this question.
Okay,
right?
okay.
I was showing this table.
Yeah.
Is the table visible?
Yeah, table. Table, your screen is visible, sir, not table.
Okay.
That's why you are confusing. Table is
okay,
visible.
okay, fine. Actually, I could switch through the screen and it was still showing sharing. So, is the table visible now?
Yeah, now visible, sir. Yeah, this you are talking about this. Sir.
Yeah. So see, we have converted that Unicode, taking the information from that. We converted that Unicode into binary bits. Now, what we need to do is
Sir, what is the difference between the code point and Unicode? Same thing is that.
Okay, where did you see the code point?
Yeah, in the lecture, the code point was there. Sir. U plus 004, U plus 05 DO.
Yeah, that's what. That is what. Yeah, both are same. Unicode code point. Okay. What is different is UTF and other things. Okay. So we have this Unicode number U plus 543A9. What we did, we converted into binary. right? And this number was hexadecimal, right? So since I said every hexadecimal number has to be converted into 4-bit binary. So since we have 5 hexadecimal digits, how many numbers will they be converted to? 20, right? So our binary number had 20 digits, which I'll show. Okay, now this table, now if we refer to this table, it says if you want to store within 1 byte, or if there are 4 bits taken in total, these are variable, right? Depending on how many free bits are there. It takes 1 byte if there are only 7 free bits. Okay, it takes 2 bytes if there are 11 free bits. Now the problem is, see, if I take one byte, there should have been 8 free bits, right? There should have been 8, but it says only 7. Okay, similarly, if I go with the 2 byte information, it should have been or it should have provided me 8 free bits. Sorry, 8 to the 16 free bits. But what we are having only 11. What is this 110 and 10 here? It is the prefix coding. It is storing the interpretation, how to interpret this information that is being followed. That is the whole idea. Okay.
This prefix was also not clear in the lecture.
Yeah,
how
that's
this
what.
was.
Yeah. So this is for computer. We don't have to understand what does that mean. This 110 and 10. The computer understands. A computer says that you have to store. If you want to store a 2-byte information, I will take 110 as my information, 10 as my information. Now remaining that you can store. You cannot simply come and take 2 bytes and store 16 bits. Okay, if some other person will come and ask me what is this, how will I show, what will I say?
Okay. It
So
is a requirement of the hardware of the computer to fix this 110 and 10 for the 2 bytes, right?
Yeah.
Yep.
So
got it.
that's what. So when we are converting into UTF, it is not only information, it is information with context. So this 110 and 10 is the context that computer requires. Okay, what is X? X means don't care. What does it say? You can store either 1 or 0. Depending on our information, it can take either 1 or it can take 0. But this 110 in the first byte and 10 in the second byte will be fixed, which cannot be altered by us or the information. Understood? This is what we are trying to see. Okay, this is written by this is what we say, interpreted by the computer. Okay, so 110, okay, it says that you are using 2-byte information. Okay, for that so computer understand, okay, there is 2-byte information that is coming, but no, not the entire 16 bits of those 2 bytes will be used as information. I will have to decode it in a way that 110 is something that computer has some rules to follow, and then the 5 digits that are followed are the actual information. Okay, so this is how the things are stored.
Hello, sir. Hello.
Yeah.
Am I audible, sir?
Yeah, you're audible.
Sir, in the first case, there are 7 free bits, right? So they must give 128 combinations, right? So why it is written 127?
No. What you're saying? Okay, so this 127 is what you're saying. This 127.
Yeah, sir. Because the 7 free bits can make 128 combinations.
Yeah, it is starting from 0, right?
Okay.
0. So, that's why it is 127. It is right.
And sir, in the last case, we use sir in the lecture. Sir said that we can't use the first 5 bits. Means from the first byte we can't use 3, and from the second byte we can't use 2 bits. So why we can't use those 5 bits?
Yeah, so that's what. So that is something that is taken by the computer to interpret what is the type of information.
No, sir. I know in the first thing at the bottom we can't use. I guess first 5 bits we can't use, but in the lecture, sir said that we can't use the 3, the last 3, and in the second byte we can't use the second 2. also. We have to store 101010 at that point.
No, see this. Are you talking about these don't care conditions? XXX.
Yeah.
No, we can store.
Possibly we'll check it. Check it and we'll let you know in the
Sir
next.
said about that five.
Okay, we'll check it out. We'll tell you in the next.
Okay, probably there must be a confusion in what was propagated. Okay, definitely we can store, right? That is the reason it is saying don't care. What does it say? What does it mean? Your information should start from here, XXX. Your information should be stored from the 6th bit. First 5 bits will not be used to store the information, but to store the context, to say that okay, this is a 4-byte information and this is how we store the 4-byte information. Okay. It would be good if you come up with the timestamp for the same, right, and put it on the discourse. Let me go through that part and give the explanation to that. Probably that was not conveyed properly.
And sir, I have a question from the next slide.
Question from next line.
Sir, in this I didn't understand why the first row has 127, and even though it 7 bits are only used, why it is not 128?
Yeah, that is what we're telling. No, if there are 128 numbers you can represent, if you're starting with 0, so it will go up to 127. No, 0 to 127, there are 128 numbers.
See, can you read the heading of the last row? Maximum expressible Unicode value. That value is a decimal equivalent of this hexadecimal code, which is 7F. Okay, so that will be the maximum value that you can store. How many numbers can be stored? Starting from all zeros to this 007F. Okay, so there will be total 128 numbers. This is the maximum value.
Oh, I got it, sir. It's
yeah. Similarly, if we see here, 2 raised to power 11 is 2048, right? So it is 0 to 2047 maximum value.
Yeah, it is fine.
Okay. Okay, so you got that. Okay, so shall I proceed with this question again?
Yeah, question.
So we are having 20 bits. So I hope this is understood that it cannot come in first 3 categories, right? The first byte,
fourth
second
category
byte.
will be applicable.
All right. Now the problem is I have a number that is 20 bits, okay, and I have 21 free bits. How should I make my number a 20-bit number into 21 bits without changing the number? You got my question?
Yeah. 21 bits are available, but we have to fit 20 bits.
Yeah.
How to accommodate?
It's simple. I guess we have done it in this session only. Yeah, somebody responded. Yeah, correct. So put extra 0 in the front, right? So if we have a number, yeah, if we have a number, let's say decimal also, there is it will not make any difference if I put 025, right? If I have a number 25, 025 and 25 are one and the same thing, right?
Put 0 in the leftmost.
Yeah, you have to put 0 in the leftmost so that you don't exactly change the number, but change the bits of number.
Got it. Yeah, fine, sir.
Okay. All right. So what I'll do is I'll do the same thing with my number. Now we are done with this table. We don't need this table anymore. And I have noted the prefix also. So we won't need this table. I'll just share the other thing, whiteboard. Okay. So this was
one question regarding table, sir.
Okay.
I will like to ask.
Yeah.
So the first byte is accommodating one more number for the first row, second row in the backend of the machine. What is the fundamental behind that? Why machine is accommodating such one more number?
Are you talking about the initial or the
Initial number,
predefined prefix coding?
Prefix coding. What is the fundamental behind that?
See, the idea is, see, I won't go into very detail like what is the fundamental,
Okay,
because I'm
or is it not
myself
required
not
to
really
know? That
sure.
is, yeah.
That's what, yeah,
Okay,
that is because it wasn't
Okay,
required,
let
so
us
even
forget.
I don't know.
Then it is,
But let me just let me give one explanation to that. See, there are some procedures which we don't know. For example,
okay.
You can create an HTML file, right?
Okay.
Just create an HTML file, okay, in VS Code. Okay, just create an HTML file in VS Code, and if you are aware of the live server extension, just use that extension and run the HTML file. Okay, now whatever I said, forget about it, because we will do that in the practical session. What happens is, if there is certain piece of information, that's what I said, there is a piece of information, you know what that information means. Okay, how to convert that information into something meaningful, which is meaningful to you. Okay, but computer has a different way, the system or the processors have different way to do that. What they do is, along with the information, they also store some bits from their own, which give the interpretation of that information. Okay, why are we storing this information? Okay, or this gives this extra bits give information to the compiler that will be interpreting these numbers later. Okay, this is how you should retrieve. Okay, so what happens beneath is at the level of microprocessors. Okay, so we don't have to worry about that. Okay, if at all you want to go through that, I'll give some, give a resource about microprocessors, how they store bits and what are the prefix bits and what are the bits that can be stored as an information. Okay,
right. Okay, fine.
Yeah, but probably that is not really required.
Yeah, okay, fine.
Okay, so what we will do now is, so what is happening here? This is a 20-bit number. I don't want to change the meaning of this number, but I want to make it a 21-bit number. So what I'll do, I'll just add a 0 here.
10 added, yeah.
Okay, now simply we have to put it wherever we have space in that coding. Okay, since we know this part, this entire bit will come in the 4th category or 4th row using all the 4 bytes. How do we put the information? It is like 1 1 1 1 0, then we have this 3 bits free, then we have 1 0, then we have 6 bits free, then we again have 1 0, then we have 6 bits free, then again we have 1 0 and we have 6 bits free. Let me check if this is correct. Okay, because this is something that I just saw from the table. Yeah, so it's 1 1 1 1 0, then 3 bits free, and then 1 0 1 0 1 0 and 6 bits. Okay, can you see the whiteboard now?
Yes, sir.
Okay, fine. So what we will do, we will just put these numbers in these places. Okay, so initially we have this 3, so we'll use these 3 bits. Okay, then we need 6. So this 1 2 3 and 4 5 6. Then other 6, 1 2 3 4 5 6, and then the remaining 6. Okay, and then we'll put these values in the places. X means any information, it can be 0 or 1. So in our case it is 0. Similarly, it will be 0 0 1. That is what it means. Okay, then we'll write 0 1 0 1 0 0. Then it is 0 0 1 1 1 0, and it is 1 0 1 0 0 1. Right, so this is our encoded number. Okay, now this is binary representation. Okay, this is also UTF-8. We have converted it into UTF-8. This is but in binary. But generally these numbers are represented in hex. Okay, so now the last step would be to convert this binary into hex. Okay, actually our work is done here, right? We converted a Unicode number into a UTF with some predefined prefix coding, but we have this binary number in place. Okay, but what we need to do is generally these are represented in hex. We have some information in hex. Let's have it in hex only. So we'll convert this into hex. Now, how do we convert these values into hex? Okay, what I'll do, I'll just write these once again in the entire complete horizontal line. So it is 1 1 1 1 0 0 0 1 1 0 0 1 0 1 0 0 1 0 0 0 1 1 1 0 1 0 1 0 1 0 0 1. So it is complete 4 bytes, right? So it is 32-bit information. Now, you may have remembered how we converted a binary number into octal. What did we do? We started off with left and made a group of 3. Why? Because it was octal. For converting a binary number into hex, what we'll do, we'll start making groups from the right of 4. That's it. That is the only difference.
Correct.
Okay, so we'll make the group of 4. Okay, and now it is very easy for me to, if you have noted the table that we have written for hex to decimal or hex to binary, you will be able to very easily able to see what values these correspond to, right? So if we see this corresponds to F, this is 1, okay, this is 9, this is 4, this is 8, this is 14, right? 14, but what is 14 in our case? It is E. Okay, then 1010 is 10, so 10 is A, and 1001 is 9, so it remains as it is. So this is the UTF conversion in hex, which is expected, right? So F 1948 E A 9, right? This is how it is converted. So I've converted a Unicode, that is information, no doubt, but that information did not have a context. Okay, we added a context with the use of prefix coding and converted it into a UTF-8, which is again represented in Xcode. This is what the question was about. Okay, any issues here? If there are doubts in conversion, I suggest you to go through this lecture once again, just to get the glimpse of how conversions are done, and then do it by yourself. Okay. Any issues here in this question?
No, sir.
Okay, so this video will be available on YouTube also, right? And probably enough sources for this question is given. But any issues are there regarding the conversions, you can again ping us on the discourse. Okay, and then this does not mean that okay, this is the only live session we have for week 2, so we cannot ask any doubts regarding week 1 and week 2 in week 3, right? That can be done. You can ask doubts of week 1 and week 2 in week 3 also, right? So this is an open session. We generally call it a practice session, but this is an open session. Okay, is it a coincidence that the last values A9 match with the original encoding? For this case, why? Because see, if I have a number that comes in the first category, okay, first category, that was if I am not wrong, it is 0 and then 7 times x, right? If it comes in the first category, sorry, my pen doesn't write from here. Just give me a minute. Right, so if this was the case, 0 0 and this, Okay, then what will happen? This last digit will not match, may or may not match. Okay, right? So it depends on the information. Okay, somebody had raised hand. Okay, so somebody had raised hand, right? Yeah, there is a hand raised. Who raised the hand?
Sir, will you be taking any questions related to the screencast of CSS?
Questions related? Yeah, sure.
Sir, is this question over? This current question?
Yeah, it's done.
Sir, in the CSS screencast, the lecturer uses combination selectors and pseudo classes.
Okay.
Can you explain something about that and how much of it is required from the course perspective? Should we require all of them, or how much of it should we know?
No. That is, if you want to see, just it is something for your information. You don't have to recall or you don't have to memorize anything. Okay, if we are using some combinator selectors, just come to know what are the various combinations that we have taken. See, if we talk about combinator selectors, there are number of combinations and number of classes made for those pseudo selectors. Okay, but we need to keep a track of only the basic ones. Basic ones as in just give me a minute. Yeah, so generally about combinator selectors, see, that's what I said. There are various combinations which can be formed, but you don't need to remember or memorize any of it. Okay, we just have to keep in mind the basics. Okay.
Can you explain simple ones, one or two?
Okay, Sonal, would you like to give some inputs on that?
Yeah. Okay, I'm audible.
Yeah, audible.
Okay, so see, we have many of the CSS selectors with us, but we don't have to go in much detail about each and every selector. So as far as our course is concerned, so we only use some of the selectors like the simple selectors like ID classes and ID classes, attribute selectors. If we talk about the combinator selectors, so see, in the CSS we have basically 2 or 3, 4 types of CSS combinator selectors. So if we go deep about some of the CSS combinators, like we have a sibling selector, we have generals, we have adjacent sibling selectors and child selectors, these kind of things, right? So you have to explore these things with your own. Like, we are not going into details about different kind of combinator solutions. So as far as this course is concerned, yeah, you can use this kind of combinators and things like that. Okay. So apart from that, we have like zero class selectors, the things that you are talking about. So see, we have like many of the pseudo class selectors, like we have hover, we have.
Ma'am, can you show one or two examples, ma'am?
Okay, so see, if
yeah, so see, here I have given a link on the chat. Okay, I've given the link on the chat. This is will give you an idea of what should be the depth of getting the understanding of CSS selectors. Okay, so this is something that you can have a look at. Again, I am not saying that you have to memorize any of it. Just have a look at it for the understanding. Okay, these are the selectors, or these are the various way in we can select. Now, to give an example on one or two, there will be a separate session on that, right? So the solve with instructor session, what we do is we create a problem statement, a very simple problem statement, wherein we deal with the content of that particular week, right? So here we are dealing with some, yeah, sorry for that. Yeah, So here we are dealing the topic our content is HTML and CSS, right? So the next session that we'll have, that is the practical part of this session, what we'll do is we'll create a short problem statement which will take into consideration the HTML and basics of CSS. There I'll try to cover 1 or 2 selectors. Okay, because
so what is the difference between children and descendants?
Children and descendants. See, children are immediate within are nested immediately. Okay, for example, I have written a div tag. Okay, and within a div tag, I have paragraph tag. Okay, now this paragraph tag is the children or child. Okay, single, right? So this paragraph tag is the child of div tag. But what if I have another paragraph tag within the paragraph tag? Okay, so in that
Are you
case,
sharing any screens that we can't
no,
see?
I'm not sharing any screen. I'm not sharing anything. Is it confusing?
No, the content.
Okay, so for example, consider a normal HTML file, okay, which will have body and all. Now in the body, I have a div tag. Okay, within that div tag, I have h1 and paragraph. Okay, now these h1 and paragraph are children of div because they are immediate within the div. Right. Now, if I have one more paragraph tag within paragraph tag, the paragraph tag which was there within the div tag, right? So what is the tree now? Div paragraph paragraph. Okay. In this case, both the paragraphs will be descendants of div. We won't say grandchild and great grandchild, right? Because there for this using great, there has to be some limitations. But descendants will take care of all the tags which are used or nested within the div tag. Okay, getting the difference. The initial paragraph in h1 are children of div tag, but the second paragraph tag, which was again nested within the paragraph, is the descendant of div. Did you get this orally? Okay, if still there is a confusion, we will we will take a session there. I'll clear. Okay, because there I'll have the code in handy, right? So I can write in and show you.
Okay.
Interactive session will be more beneficial.
Yeah, surely it will be. I mean, it will be there.
Yes, thank you.
Correct. Yeah. So there is one comment. Basically, children are first level descendant, right? So it is a first level descendant. So depending on the level, if the level increases by 1 after 1 or increases or goes more than 1, it becomes very it doesn't sound right to say great children, grandchildren, and great grandchildren, right? So we use the term descendant. Every child is definitely a descendant, but level 1, as said by Lakshminandan.
Okay, sir.
Yeah, so it will be clear. I'll try to take some I'll try to add that part also in the problem statement so that we deal with that. Okay. Meanwhile, you can go through this link that I've given. This is again the link from MDN Docs, which we generally ask you to recommend to refer. Sorry. Okay. Any other doubt? No other doubt?
No, sir, fine.
Okay, fine. So I'll consider this to be temporarily temporarily. You don't have any doubts on this topic, but yeah, so they will appear and we'll try to clear them in the forward coming sessions, right? So don't worry about that. If there are any doubt and you want immediate response to that, don't wait for the live sessions. You can definitely put it on Discord and we'll try to respond there. Okay. So I guess probably with that we can conclude this session if there are no more doubts.
Yes, sir, we can do.
Okay, fine. Okay, fine.
Thanks
so
for
we'll all right. So we'll call it a day for today. We'll meet on the next session, which is practical session.
So one last doubt before you
we'll
close.
do interactively, sir. In the practical session, we'll do interactively.
Yeah. Go ahead. Yeah, somebody was speaking.
Yes, sir. So I had a doubt key in the HTML lab assignment which we are submitting. Can you elaborate on the type of tests that are involved?
Type of
tests that are involved.
See, if you create a document, if you refer to the problem statement and you give your preliminary submission and you go with the test run, okay, test run will give you basic level of testing that we are doing. That will give you an idea of what kind of test we're doing. Okay, and I'm definitely
Can you
not.
Elaborate what is being tested there?
Yeah, so the use of tags, right? What kind of tags you have used, how you have created the document, how is the structure maintained, right? Is the your HTML file rendering or showing on the browser the way we want it to? And as I mentioned before, right, multiple HTMLs can show the same thing, but the way we want is to be done is the way it is explicitly given in the problem statement. Okay, so you have to refer to the problem statement very carefully, use the frequency of tags properly. If you are missing out or using any extra tags here and there, definitely it will definitely cost you. See, you have to understand that this is any, if at all it is giving the right or the correct screenshot, it is matching with the screenshot, but we want you to follow a pattern, okay, that makes the evaluation very easy or and smooth. With the smooth, I mean it becomes it makes the evaluation unbiased. Okay, so you have to strictly follow with the frequency of tags and all that are being used. Okay, so the test cases that we have defined internally somewhere test these things.
So what are code generators which we should not use?
See, there are various HTML code generators you will find online, which you will, just write something and then it will give the HTML, created HTML for that. Okay, so that is not the right practice, right? Because you won't learn anything from that.
So if we add an additional meta tag, would we lose marks for that?
Yeah, definitely.
We would be losing marks if we add additional meta tags which are not required in the problem statement.
That's what, yeah. So that's what. So the frequency of tables have to be maintained very carefully because it's not only missing out on some tags. You have to add extra tags also. Why? Because if some functionality is achieved with minimum usage of tags, why to use extra tags? That is the whole idea, right? So we have to optimize. And the optimized frequency is something that we have given.
Okay, sir.
Yeah.
So in last clarification, no CSS is to be used, inline, external, for the HTML.
No. If at all you want to use any CSS, just create your own code which you won't be submitting, right? And then you can add any type of CSS you want. Okay. If proceeding forward in the weeks, we'll also study about some HTML code generators by ourselves and also see their limitations and also see their advantages. Okay. Spacing and indentation could differ. See, I cannot talk about each and everything right at this point. But the test cases, the public test cases that we have given will give you a clear idea of whether something has to be taken care of or not. Okay, those are superficial cases, but they give you enough idea. Okay, yeah, so there was a question on that. That's why I said that. So I cannot specifically answer to each and every question just before the deadline, right? And you give a preliminary submission, and whatever test case you fail or whatever you pass will all be given as an output, and you'll understand, okay, this is being checked and that is not being checked. ID sometimes, yeah, that is okay, no issues. If you have given, if you have not copied the HTML code, it will not generate any indentation error. Don't worry. Okay. Is there any other thing that I'm missing? Somebody asked something, I'm missing something. Is it like that? Yeah. So for the HTML code generators, you can simply type on Google it, HTML code generators. You'll find plenty. Okay, but we want you to be able to write the HTML rather than simply creating it for creation. So that is the thing. That is what we refer with that point. Use of HTML code generator is strictly prohibited. Okay, fine. All right. So with that, should we end this session if there are no doubts?
Yes, sir. We can.
Okay. So we'll meet
it was a very nice session, sir. Thank you very much.
Okay. Thank you. So probably there is a change in timing for the next session, right? It will be communicated to you, but I guess the next session that we are talking about, the Solve with Instructor 1, would be on Friday. Okay, the timings I'm not really sure. I guess it is 2 to 4, but it will be communicated to you. Okay, but if you can just have an idea of that okay, there is a change in the session timing for the coming session only, not the others. Okay.
Okay.
Yeah. So next session would be probably on Friday rather than on Saturday. Yeah. So the information on that will be communicated.
Okay. Thank you.
Okay. Fine. All right. Okay, so we'll officially close this session. All right.
Yes, sir.
Good night and see you later.
Thank you, sir. Thank you very much.
Thank you.
Thank you, ma'am.
Thank you, guys. Thank you.
Thank you, sir.